Okay, folks, it's lesson 6, connecting similarity and transformation. So the cool down says determine if each statement must be true, could possibly be true, or definitely cannot be true. Explain or show your reasoning. So the first thing I would underline on that is the word must. The second is could, and the third is can't. So you got to determine these two statements: must be true, could be true, can't be true. So congruent figures are similar, similar figures are congruent. You'll see on the cool down there's no figure to help you. So I want to teach you a cool skill in geometry. This is a very, very big skill in geometry. It's called drawing ideas in helpful ways. So if you can draw your ideas in helpful ways, it'll help you a ton. Now, before I started this video, I worked on this, and I was recording it actually, but I realized it was taking too much time, so I stopped the video and started over. But this is what I did to help me. Now, do I expect you to do all this? Nah, no way. But do I expect you to start using color? Yep. Do I expect you to start using your tools? Absolutely. The prettier that you make your artwork, the more likely it is that you're gonna look back and study it. So if you make your workbooks just look beautiful as best you can, you should find that it'll be more interesting to look at later. So here we go. So congruent figures are similar. Well, let's talk about the differences between congruence and similarity. So let's first talk about congruence. So congruence means essentially, and this is the easiest way to define it. So you're gonna have two figures. So two figures. Same size, same shape. So the exact same size, the exact same shape. You might use that in home building. So say you're a construction company and you got to build a bunch of homes that are the same size and the same shape. Those would be what's called congruent. Now let's do a little versus. Similarity. So similarity. Almost always it's going to be two figures. I mean, it could be more than two, but it's usually two figures. They're not necessarily the same size, but they are definitely the same shape. So they similar figures have to be the same shape. Now, for size, you would look at the lengths of the sides. For shape, you would look at the measures of the angles, if you want to be even more specific. So we're looking at the battle between congruence and similarity. So what I did is I created A, B, C. And this is known as the pre-image. Now, just a quick definition, the pre-image, that's like your starting figure. So that's your starting figure. right? That's the first one, the pre-image. The images are going to use like prime labels. So what I did, just to convince you, is I took the points here, and then I moved my patty paper down here. I put like a pen indentation, and then I redrew the points, and I relabeled the points A prime, B prime, and C prime. All right, so the two blue triangles, A, B, C, and A prime, B prime, C prime, they're the same size and they're the same shape. They're also similar because they are the same shape. So they're congruent because they're the same shape. They're also similar because they're the same shape. So congruent figures are similar. Just think about this. If congruence is already specified as the same size and the same shape, and similarity is only the same shape, that means that all congruent figures are also going to be similar. So this one is must be true. And on your test, you're gonna have to write like because ... So let's create like a sentence frame right here. I'm just gonna write right over it. So congruent figures must be similar because all congruent figures are the same shape. This is definitely the criteria. You could call it a definition. Of similarity. So because all congruent figures are the same shape, look at the two blue triangles, you can also conclude that they are similar. Okay. Similar figures are congruent. Okay, so here's our starting triangle, which was shaded in light blue. This is a new triangle. It's a different one. And how do you know? Well, it's got the prime labels. So the two blue ones are exact copies. And remember, I used patty paper. So the two blue ones are both congruent and similar. Now what I did on your picture here is I made the green one twice as big as the blue one. I just measured and then doubled that, measured and doubled that, measured and doubled that to get my new points. So these points are called vertices. So there's a vertex, a vertex, a vertex. The plural of vertex is vertices. So if you ever see vertices, that's the plural for vertex. That means all the points, essentially. So synonym for vertice is the points. Okay, so let's look at the green. So you got the blue here. We decided these are both congruent and similar. Let's look at the green. The green is not congruent to the blue because it's not the same size. However, as you can see, I did a dilation, and in dilations, the angle measures don't change. So, the green, in comparison to this one, the pre-image, same shape, but not the same size. So the green is just similar. Now the next one is the orange. Just color it in just to make it pretty. Now again, we're comparing everything to the pre-image up here. So the orange, much like the green, I used the scale factor of 4 for the orange. That's similar. And why don't I just say A, B, C. Just put it all. Triangle similar to triangle ABC. Similar to triangle ABC. Okay, so this first one, A prime, B prime, C prime, is congruent, similar to ABC. This green one right here, it's similar to ABC, but it's not congruent because it's not the same size. And the orange one, also similar to ABC, but it's not congruent because it's not the same size. So, similar figures are congruent. Well, this is an example of a figure that is both similar and congruent to our pre-image, our first. However, the green and orange are not congruent to this blue one. So similar figures are congruent. That is going to be, instead of must, that is going to be could possibly be true. Now, what's the only instance where it could possibly be true? Well, that's if the scale factor equals 1. And if the scale factor equals 1, it'll be both similar and congruent. If the scale factor is any other number other than 1, well, anything 0 to 1 or bigger than 1, then it'll only be similar. So your answer is could possibly be true. Now, how would you write that? It could possibly be true only if the scale factor equals 1, or in other words, if the figures are congruent. See the two blue ones. All right, that's the cool down. I realized I went like way in depth on that and I took a long time, but it's a tricky question and I wanted to really explain it and I wanted to use some color. So that was lesson 6, connecting similarity and transformations. All right, that's out of here. Okay, next up. We got 6.1, dilation miscalculation. Okay. So, what's wrong with this dilation? That's what they're asking us. What's wrong with this dilation? So here's obviously the center of your dilation. This is your original figure. There's a couple things wrong with it that I can see right off the bat. But that's a square, if you ask me. I haven't measured the sides, but they all look like 1 inch. Let's just triple check. Yeah, 1 inch. 1 inch side squares. This looks to me like a rectangle. So square versus a rectangle. Well, the two images are not the same shape. What about the vertices? Remember that word vertices we just talked about? AKA points. So the points have to be in line with the center. So P, D, and H, those are in line. What about P, C, and F? Nope. So, I can show you what we would need to do here. So P, C, and F prime, or the correct F should be on this line. So the intersection of these two lines should be right here. So this is where F should be. Oh my, lost track of time. Okay, I'm gonna hustle. But dilation miscalculation, square cannot become a rectangle. All right, let's talk about the card sort. I gotta hustle on the last two. All right, card 1 is a dilation only. That's the only thing. So ORQ dilated to ONP. Card 2 is a translation plus dilation. This is all we need to do. Translation plus dilation. Card 3, look at these figures. These are not the same shape because this angle is not the same as this one. So not the same shape. So not the same shape. Therefore, not similar. Not a dilation. Let's look at card 4. These are congruent shapes. So F and G are congruent. Let's look at card 5. This one is going to be a translation, rotation, dilation. So translation, rotation,
and dilation. Last but not least, this one's going to rotate, translate, and reflect. Those are the rigid motions, so that means they are congruent. I got 2 minutes for the last one. That's all I need you to know on these card sorts. So, are the triangles similar? Well, the first thing I notice is there's an angle. There's a second angle. And a third angle is the right angle. Yes, they are. Why? All the angles are the same. All the corresponding angles are the same measure. Write a sequence of transformations. Okay, so we're going to translate via QA. So if you move Q to A, you're going to end up basically like right here. In the interest of time, I got to kind of speed ahead, I mean. So 3.2 and 6, and then you got 6.8. You're going to notice that 3.2 times 2.5 will equal 8. 6.8 times 2.5 will equal 17. And 6 times 2.5 will equal 15. So in all instances, it's A times scale factor equals A prime. So the next move is a dilation. You got to talk about your center, which is going to be A. Your scale factor equals 2.5. And the figure you're dilating, this is kind of tricky, is going to be Q prime T prime R prime. Write a similarity statement about the two figures. Explain how you know they are similar. Well, you're going to say triangle QTR is similar to triangle AEB. How do you know? Well, all corresponding angles have the same measure. The other way you could say this is the definition of similarity, which is a sequence of rigid transformations and dilations will take one figure to the other. All right, I gotta go. I got a meeting. Again, use color with your drawings and try to have as much fun with artwork as you can. Okay, bye.